Dear students, we are now going to study Ohm's law, which is one of the main part of this chapter. Let us go through the statement given by Ohm. The potential difference across the ends of a given metallic wire. Now I mentioned metallic wire is a conductor through which electric current can pass. So the potential difference V across the ends of a given metallic wire in an electric circuit is directly proportional to the current. It is electric current flowing through that metallic wire, provided its temperature remains the same or the temperature remains constant. Temperature is one of the physical conditions which must be kept constant, otherwise there will be the variations which we are going to see next. Let me show you through an equation. V is the symbol for potential difference and I is the symbol for electric current. So as per the law, if the potential difference is applied at the two ends of the conductor, that is V, electric current will be flowing through it, which will be proportional to potential difference. So V is proportional to potential difference. Now if we take out a proportionality sign, then V will be equal to I, and it is multiplied by a constant called proportionality constant R. Now as per Ohm's law, R, which is a constant, is considered as resistance of the given metallic wire. Actually R is a constant, so actually I can write R will be equal to V upon I, where the ratio of V and I will remain constant, so that we can say resistance is one characteristic of a given material. So we can say that potential difference applied across the two ends of the conductor is directly proportional to the current flowing through it. This is a linear relation, so if we make a graph out of it, on which on y-axis I substitute potential difference and on x-axis if I substitute electric current, then the graph will be linear in nature. This is actually a linear graph where V is directly proportional to I, which is representing that if we select any one point, we can consider the values of current. If the value of potential difference is increased, the electric current will also increase. So this is a linear graph showing Ohm's law. So as per the statement given by Ohm, V is equal to IR is Ohm's law's equation, where R is actually a proportionality constant, but it is mentioned as one characteristic of a material, and unit to measure resistance is Ohm, as it is named after the physicist. This is the symbol of Ohm. So whenever you are measuring resistance, unit to measure resistance is Ohm, V is the potential difference, and I is the current. So as per we discussed, whenever we apply potential difference, it will always be proportional to electric current. That means if we increase the potential difference, there will be increase in the current flowing through the metallic wire. So to learn that, let us watch one video to get some detailed information.
What is a resistor? A good definition would be a resistor is an electrical component that limits or regulates the flow of electrical current in an electronic circuit. The symbol in the left is the American standard, while the symbol in the right is the international standard. To explain the definition more clearly, we take an example of a water flowing through a pipe. It is same as current flowing through an electrical circuit. But if we make the tube narrow from any point, then the water flow reduces. Resistor is same as that narrow tube and it opposes and reduces the flow of current through it. The relationship between voltage, current and resistance is given by Ohm's law. Mr. Ohm was a German scientist who discovered the Ohm's law in 1827. That is, electrical resistance is equal to voltage upon current, where voltage is given by volts, resistance is given in ohms, and current is given in amperes. A simple circuit with a battery and resistor can explain it. The voltage source produces a current that is limited by the resistor. If voltage is equals to 2 volts and current is equals to 4 amperes, then what should be the resistance of the resistor? Simple. Resistance is given by voltage upon current, therefore 2 by 4, that is 0.5 ohms. Suppose we need to lit a red LED having maximum current carrying capacity 30 mA with 9 volts of battery. If we directly connect the battery to the LED, then the LED might burst out instantly. LED practically doesn't create resistance, so the current will get much higher than 30 mA. To prevent this, we need to connect a resistor in between the battery and the LED. The value of resistor is decided by Ohm's law. Hence the LED will glow without any damage.
So we learned many things in Ohm's law. I think the video gave a proper information about it. But let us move further in this concept. Let me show you when can we say that the resistance of a resistor is considered as 1 ohm. If we write Ohm's law, V, which is potential difference, is equal to electric current and it is multiplied by resistance. So if I make R as the head of the equation, which will be equal to potential difference upon electric current. Now let me tell you that if there is a conductor, a metallic wire, and it is connected to a cell or a battery, then potential difference is applied between these two ends. If we increase the value of resistor, the current through it gets decreased. Let us say if I increase the resistance 2 times, the current through the resistor will become half. Okay, now if I want to know that when can we say that the resistance of a resistor is 1 ohm. So for that I will write that if 1 volt of potential difference is applied across the two ends of the conductor and current passing through it is 1 ampere, then the resistance of the resistor is considered as 1 ohm. This is the symbol of 1 ohm. I have drawn one simple circuit in which this is a metallic wire connected to a battery or combination of cells. Now this is closed connection, that means electric current is going to pass through this metallic wire. Now this metallic wire is having one characteristic, that is resistance. It will actually resist the flow of charges. And this flow of charges are none other than actually group of electrons which are flowing through the conductor. That means electric current is constituted by group of electrons, and the path or the motion of electrons are actually opposed by a characteristic of a material called resistance. So the flow of charges are restricted by a property called resistance. Let us define variable resistance, or let us say a variable resistor here. So I am drawing the diagram of a variable resistor which provides variable resistance. Actually, variable resistor is a component used to regulate current without changing voltage source. So it is used to regulate current without changing the voltage source. Rheostat. The symbol of rheostat can be drawn like this, having 3 terminals. It is a device often used to change the resistance in a circuit. So this is a rheostat. So this was all about Ohm's law, but in next we are going to understand the graphical representation of Ohm's law.